It was pleasure being here today to explain you about conformal mapping. I would like to draw your attention towards what is this mapping or transformation and this the definition of this conformal mapping. See here the mapping by general analytical function W is equal to f of z. A special claim mapping will be defined to be conformal mapping. These mappings are important in engineering mathematics and solving various problems in two-dimensional potential theory. So let me explain you what is this mapping or transformation. Both are same. See here there are two types of functions. One is a real valued function and the next one is a complex valued function. In real valued function, see here y is equal to f of x. Generally it will be in terms of x comma y. So if I take f of x is equal to x square. See here, y will be, so y, what will be the y value? So y is equal to x square. So here there are two variables x and y we can easily represent in a graphical notation. So if I take a few values here for x and y values will be varying depending upon the x values. See here, these are x values and these are y values. So y is equal to x square here. So if I take minus 2, minus 1, 0, 1 and 2. So what will be y value? Y value is equal to x square. So here this will be minus 2 whole square, the value will be 4. And next minus 1 whole square, the value will be plus 1. And 0 square is 0. Here x square, 1 square value is 1 and 2 square value is again 2 square value is again 4. See, this is very clear that we can represent graphically. So as we can take x-axis and y-axis. So this is x-axis and this is y-axis as this is 0. So we can take 1, 2, 3 and here also minus 1, minus 2 and minus 3. And here what are the values here? So this is 1, this is 2, this is 3 and this is 4. See here for 0 the value here is 0, clear. And see here for 1 the value here is 1 and for 2 the value here is 4, clear. And next one for minus 1 the value here is 1. For minus 1 the value here is 1. And for minus 2 the value here is 4. For minus 2 the value here is 4. So there is a graphical representation like this. Clear? So this is how we can represent for y is equal to f of x. So y is equal to f of x, we need an xy plane. This is x plane and this is y plane. And it is very easy and this is for a real valued function. And now coming to the complex valued function, so we have w is equal to f of z. So here there is x square, I am taking z square here. So what is f of z? F of z is nothing but w. See, clear? So w is equal to z square. So obviously w is equal to u plus iv. And z will be representing x plus, see here, x plus iy. So here in place of w I am writing u plus iv and in place of z I am writing x plus iy. So this value is whole square. So this is u plus iv is equal to, if I make a square, this will be a square, this will be b square plus 2 into a into b. Clear? This is u plus iv value, it is very clear as x square. I square value is minus 1 and clearly this is minus y square. So if you multiply all these, this will be 2xyi. And see here, if you adjust the real parts as u and the next one as imaginary parts. So there is I here as v. So here u value will be x square minus y square and v value will be, this is 2xy. See here, they are x, y, u, v. There are 4 variables here. In order to represent through graphical notation, we need a 4-dimensional graph. So is it possible? No, it is not possible. For xy, we are going to take one plane. For uv, we are going to take one plane. So for xy, so we are going to use a z plane and for uv, we are going to take a w plane. So here there is an adjustment between the 4 variables, that is x, y and uv. So for representing on the graph as like this a real valued function, it is not possible. So this is x plane and this is y plane. It is enough for this, a real valued function. For the complex valued function, there W as well as Z. So for W, this is U plus IV, and for Z it is X plus IY. So there are four variables and there is no 4D graph, and therefore we are going to represent W in one plane and Z in one plane, and we are going to show a mapping or a correspondence between the two planes here. See here XY. So for example, if I take Z is equal to, so if I take Z is equal to 1 plus 2y, on comparing, so what will be this one? So on comparing with Z is equal to, this is X plus IY, so X value is equal to 1 and Y value is equal to 2. Clear? So we have to change in terms of UV. So here what will be the U value? X square minus Y square. So X square value is equal to, this is 1 square minus this is 2 square. So U value is equal to 1 minus 4. So U is equal to minus 3. And see what will be the V value. So V is equal to 2xy. So this is 2xy. V is equal to 2 into 1 into 2. V value is equal to 4. So UV, in terms of UV, the value is minus 3 comma 4. In terms of XY, the value is 1 comma 2. And now we have to represent both. So in W plane as well as XY plane. So I am taking two graphs here. The first one is the Z plane. So in the Z plane, see here. So Z plane, the value here is 1 comma 2. So this is 0, this is 1 and this is 2. This is 1, this is 2, this is 3 and so on. So as this is Y plane and this is X plane, so I am taking this as a Z plane. So now I have to represent this one. Z is equal to 1 plus 2i. So 1 will be this one and 2 will be this one. Now I have represented this point like this. And next one here, if you observe this one, so we have to take UV on W plane. So I am taking this as a W plane. See here. So this is a W plane. So here this is minus 3. So this is minus 1, minus 2. This is minus 3 and so on. So I'm making a partition here. This is 1, 2 and 3 and this value is 4. See here, this is 1, this is 2, this is 3 and this is 4. So now we have to represent this one. So minus 3 comma 4. So here will be the point here. So if you observe, this is W plane and this is Z plane. So this value is a Z plane. So if you take like this a few set of points, so here the curve 1 will be like this, C1 will be like this, and if you take another set of points, the curve will be like this, C2. Clear? And see here, same as this. So if you take a few set of points, the curve will be like this, C1, and the next curve will be like this as a C2. So here is a connecting point. So here we have to take as P and here we have to take as P dash. And see here, we are making an angle. So which is rotating in an anti-clockwise direction, make it as alpha. And here it is making an anti-clockwise direction, alpha. So here is a mapping. So first of all, we have to understand that in a real valued function, so it is a graphical representation in XY plane. So it is a two-dimensional graph. Whereas in a complex valued function, you have to understand that there are two variables, W as well as Z. W is again represented in terms of UV and Z is again represented in terms of XY, and there are altogether four variables, that is U, V, X, Y. So in order to represent all the four variables, there is no four-dimensional graph, and therefore we have to adjust like this as two graphs. One is a Z-plane graph and next one is W-plane graph. So in Z-plane graph, see here, in Z-plane graph we have to represent XY points, and in W-plane graph we have to make a representation of UV. So U comma V points, and therefore for a complex valued function there are two planes, that is Z plane as well as W plane, which we make a correspondence. So here, what is this? This is the mapping. And see here, let me explain you what is a mapping. The correspondence defined by the equation W is equal to F of Z, where W is equal to U plus IV. And between the Z plane and the W plane is called the mapping. The correspondence between the W plane as well as the Z plane is called a mapping or a transformation from Z plane to W plane. the corresponding points W in the W plane. So here W in the W plane is called the images of the points of Z in the Z plane. See here, W points are the images of the Z points. If for every point of Z there is a correspondence, one and only point in W plane. So here there is only, for one point there will be one point in W plane. If there is another point, there will be another point in Z plane. So there is a one-to-one correspondence between the Z plane as well as W plane, and therefore the points in W plane will act as an images of the Z plane. Clear? And here this is the mapping. So here the mapping is however represented as Z is equal to X plus Iy in Z plane, and the correspondence to W is equal to U plus Iy in the W plane. So this is the graphical correspondence between the two planes, and this is called mapping or the transmission. When you say that this mapping or the transmission is a conformal mapping, so there are special cases here. So when we say, so if the angle between the two graphs here makes an equal in magnitude and equal in direction. So if the magnitude of both the angles are same, both Z plane and W plane are same, and making the direction anti-clockwise in both the graphs, then we say that this type of mapping or the transmission is called the conformal mapping or the conformal transmission. Clear? So here the angle should be magnitude equal and direction also equal. So direction should be in an anti-clockwise direction. Both should be same. Then we say that such a correspondence or a transmission is called a conformal mapping. If not, if the magnitude is same and we have a different direction, then we say that it is an isogonal. So the mapping is called an isogonal. So it is very easy and very understandable here. There, if you take two functions here, y is equal to f of x, there are two variables here, so there is a clear cut graphical representation in an xy plane, so there is no worry for that. And for the complex valued function, there are two variables, that is w as well as z. W is represented in terms of u and v, and z is represented in terms of x and y. So here altogether there are four variables, that is x, y, u, v. So for altogether four variables, there is no 4D graph, and therefore we have to adjust in the two graphs, that is Z plane as well as W plane. In Z we are going to represent XY, and in W we are going to represent U as well as V. So UV. So here altogether the four variables XY in Z plane and UV in W plane. So here there is a correspondence between the two planes, Z plane as well as W plane. We say that this correspondence between the Z plane and W plane is called the transmission or the mapping. Clear? So the correspondence between the two planes is called the mapping or the transmission. So as it is very clear that the corresponding points in W plane is called the images of the points of Z in the Z plane. So these are all the images of this one. For one point, there exists one point here. There is a one-to-one correspondence between the two planes. And here is another point, that when we say that this mapping or this transmission is a conformal mapping or a transmission. So when the angle made by the two curves will be having a same magnitude and same direction. So the direction here should be in an anti-clockwise direction. So it should be in an anti-clockwise direction and it should maintain the same magnitude. Then we say that this type of mapping is called a conformal mapping. So here is a clear-cut idea on conformal mapping. In my next video, I am going to post so many problems related to this series. Don't miss that. If you really like this one, so if you really understand this one, please pass it on to as many friends as you can, or you are going to support. Thank you so much for watching and staying till the end.